Okay, let's now talk about triangles. So what is a triangle? A triangle is simply a plane figure bounded by three straight lines. Right, so as you can see, 1, 2, 3, you get a triangle. The word tri means three, right? Whenever you hear of tri has to do with three. So trinity means three, right? So triangle means three angles, right? So it means that in a triangle you have three different angles, right? You have three different angles, right? So you have one angle here, one angle here, and one angle here. That is why we call it a triangle. Okay, so let's look at the various types of triangles. So we have about I think it's rather 4 types of triangles, right? So we have the equilateral triangle, the isosceles, the scalene, and the right angled triangle, right? So let's look at each one of them. So what's an equilateral triangle, right? So equilateral triangle is any triangle that has all 3 sides and 3 angles equal, right? So this is how we represent equilateral triangles, right? So you usually see these 3 marks, right? These 3 marks. So and they are of the same number. So if here is 1, here to be 1, here to be 1, and whenever you see these marks on a triangle, it tells you that that triangle is an equilateral triangle, meaning that line AB is equal to line AC is equal to line BC, right? So it has all 3 sides and all 3 angles equal. So here to presupposes that angle X and angle Y and angle Z are the same, right? They are the same. So for an equilateral triangle, each of the angles is equal to 60 degrees. Later on we would find out why each of the 3 angles in an equilateral triangle is equal to 60 degrees, right? We'll find out very soon, right? Okay, let's move on to the isosceles triangle. So this is a triangle with just 2 sides and 2 angles equal, right? So if you take triangle XYZ, line XY is equal to line XZ. So as you can see, here it has just 1 stroke. This line also has 1 stroke, but YZ has double stroke. So it means that the 2 sides that has the same stroke, the same number of strokes, are equal, right? So this one means these 2 strokes means that it is not the same as the other 2 sides, right? So we say it has 2 sides and 2 angles equal. So if XY is equal to XZ, then angle XYZ, that is angle A, is equal to angle XZY, that is angle B, right? So the angle formed at these 2 corners are also equal. That is when the angles at the side here are, so when the lines at the side here, right, are equal, of equal length. So that is isosceles triangle. Okay, let's proceed. Okay, the third one is a scalene triangle. So this triangle has no sides and no angle equal, right? So line AB is different from line AC, is different from line BC. They have different lengths. Right? So as you can see, line AB has just 1 stroke, AC has double stroke, BC has triple strokes, right? So this tells you that they are of different length, right? They have different sizes, and they also have different angles, right? Different angles. So angle X is not equal to angle Y and is not equal to angle Z, right? So none of the angles are of the same value. So that is what we refer to as a scalene triangle. And finally, we have what we call the right angled triangle, right? So when we're talking of the types of angles, we made mention of the right angle. and we said the right angle is an angle that is exactly at 90 degrees. So a right angle triangle is a triangle that has one of its interior angles at exactly 90 degrees, right? So there is a symbol for 90 degrees. So whenever you see this mark, like I told you earlier, it means that it is at 90 degrees, right? So any triangle with one of its interior angle at 90 degrees is a right angled triangle. Okay, let's proceed. Okay, still on triangles, let's look at the two kinds of angles that are formed whenever we have a triangle, right? So we have the interior angles and then the exterior angles, right? So let's start with the interior angles. So interior angles are angles formed within, as the word suggests, interior. So they are formed within the triangle, within the borders or within the boundaries of the three lines, right? So we have angle A, angle B, and angle C. Now the interior angles of a triangle sum up to 180 degrees. They sum up to 180 degrees, so you have to take note of that, right? Interior angles of a triangle sum up to 180 degrees, right? So let's come back to the equilateral triangle. I said I will explain to you why each of the interior angles of an equilateral triangle is 60 degrees. So we said the sum of interior angles of any triangle at all is what? Is 180 degrees. And since all the three angles are equal, to find one angle you just divide 180 by what? By 3. So what is 180 divided by 3? It is 60 degrees. That is why each of the angles of an equilateral triangle is equal to 60 degrees, right? So that is just to give you more insight into why each angle of an equilateral triangle is 60 degrees exactly. Okay, so we have a practical question here, right? So we have to find the value of x in this diagram. So now clearly you can see that triangle ABC is an isosceles triangle. Why? Because now these two strokes you are seeing there tells us that line AB is equal to line AC, right? And it presupposes that it is an isosceles triangle, right? So for an isosceles triangle, it means that angle ABC, the angle formed here, angle X, is equal to angle ACB, right? Good. So ABC is equal to ACB is equal to X. So it means we can represent this side to as X, right? Now we also said that the sum of interior angles of any triangle at all is 180 degrees. So angle BAC, that is a 40 degrees, plus angle ABCX plus angle ACB, another X, must be equal to what? 180 degrees, right? So we simply have 40 degrees plus x equal to 180 degrees. So you're going to have 40 plus 2x being equal to 180 degrees. So 2x is equal to 180 degrees minus 40 degrees. 2x equal to 140 degrees. You divide both sides by 2, you have x to be equal to 140 over 2, and that gives us 70 degrees. Right, so it means that the value of angle x is what? Is 70 degrees. Right, so you just apply your knowledge on isosceles triangle and the sum of interior angles of a triangle. Right, okay, let's proceed. Let's now look at the exterior. So exterior angle is the angle formed outside. So interior is inside, exterior is outside. Right, so let's look at this example here. So when you look at this diagram, now angle X here becomes an exterior angle, whereas Y, Z, and M are all what? Interior angles. So for an exterior angle, it is an extension to what? To the interior angle, but then it comes outside. Right? If it is from outside the boundaries of what? of the three lines. So angle X is an exterior angle. So let's look at some properties of exterior angles of a triangle. So the first property is that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Right, so what this means is that when you take angle X outside here, it is equal to the sum of the two opposite interior angles. What are the two opposite interior angles? Y and Z. So it means X is equal to Y plus Z, right? So that is one characteristic of the exterior angle of a triangle, right? So one exterior angle is equal to the sum of two opposite interior angles. So X is equal to Y plus Z. So that is the first characteristic. Now the second characteristic is that the exterior angle and its corresponding interior angle are supplementary angles, right? So whenever you have an exterior angle, like I told you earlier, an exterior angle is an extension of an interior angle. So the interior angle plus its corresponding exterior angle sum up to 180 degrees. So here, for instance, angle M plus X must be equal to 180 degrees. The reason is that obviously this interior angle and this exterior angle are all on a straight line. They all rest on a straight line, right? And we said the sum of angles on a straight line is what? Is 180 degrees, right? So that is why we said the exterior angle plus its corresponding interior angle must sum up to 180 degrees. I believe it's well understood. Okay, let's take a look at this question here. So in this diagram, we have to find the values of angles A, B, and C, right? So we are going to apply our knowledge on interior angles and exterior angles, right? So clearly you can tell that 110 is an exterior angle and 124 is also an exterior angle, whereas angles A, B, and C are all interior angles. So let's start. So if we want to find angle A, well, we can say that 180 degrees plus angle A must sum up to 180 degrees, because we said the interior angle plus its corresponding exterior angle must sum up to 180 degrees. So clearly, to get angle A, we just have to add up A to 110, and the total must give us 180 degrees. So A is equal to 180 degrees minus 110 degrees, and that gives us 70 degrees. So that is for A. Now let's come to C. So to find C, obviously we say C plus 124 degrees must be equal to 180 degrees, right? Because they are on a straight line, right? So interior plus its exterior must be equal to 180 degrees. So C is equal to 180 degrees minus 124 degrees, and that gives us 56 degrees. So we are left with angle B. Now you can solve this in two ways. First of all, now that you've been able to find the value of A and C, you can find B, because the sum of interior angles in a triangle is 180 degrees. So it means that if you want to find B, just add up angle A, that is 70 degrees, to angle C, 56 degrees, and then subtract the total from 180 degrees. It will give you the value of B. So let's try that one. So what is 70 plus 56? That gives us 126 degrees. So when you subtract 126 degrees from 180 degrees, what are you going to get? You are going to get 54 degrees, right? You can use your calculator to check. So 180 degrees minus, that is 70 plus 56, giving us 126. It will give you 54 degrees. Alternatively, you can use the idea of one exterior angle is equal to the sum of two opposite interior angles, right? You can use that principle to help you find the value of B. So it means that when we take 124 degrees, 124 degrees must be equal to A plus B, right? So A plus B is equal to 124 degrees. So our A, we found it to be 70 degrees, so it means 70 plus B is equal to 124. So our B is equal to 124 minus 70 degrees, and that would still give you 54 degrees, right? So that is how we have solved this simple question, right? So we just apply our knowledge on exterior angles, interior angles of a triangle. As simple as that, right? Okay, let's move on. Alright, let's now discuss polygons in general. Polygons, right? So what is a polygon? A polygon is simply a plane figure bounded by straight lines. Bounded by straight lines, right? And we say polygons may be regular or irregular. Right, so a regular polygon is any polygon that has all the sides and angles equal, whereas an irregular polygon does not have all sides and all angles equal, right? So in relation to triangles, we can say that the equilateral triangle is a regular triangle or a regular polygon because it has all three sides and all three angles equal, right? And we can say that the scalene triangle is an irregular polygon or an irregular triangle because none of the sides as well as none of the angles are equal, right? So that is what we refer to as polygons. Any plane figure bounded by straight lines. So with a triangle is bounded by three straight lines, right? So we have different types or different kinds of polygons based on the number of sides. Right? So basically the least or the smallest polygon in terms of size is the triangle, right? So for you to have a polygon, at least you must have three straight lines. So a triangle is the most basic unit of a polygon, right? But then we have larger ones, or we have other polygons with more sides. So we have those with 4 sides, 5 sides, and it goes on and on and on, and they all have special names, right? They all have special names. So let's look at their names based on the number of sides they possess. So with a 3-sided plane figure, we call it a triangle. Now a 4-sided polygon is known as a quadrilateral. But then we have different kinds of quadrilaterals, right? We have the square, we have the rectangle, we have the kite, we have the rhombus, the rhomboid, we have the trapezium, right? So these are all quadrilaterals, right? But then the regular amongst it is what? Is the square. So the square is the regular quadrilateral. So a 5-sided plane figure or polygon is known as the pentagon. A pentagon. So a 6-sided plane figure is a hexagon, 7-sided is heptagon, 8-sided is octagon, 9-sided is nonagon, 10-sided is decagon, 11-sided is undecagon, and then 12-sided is duodecagon, right? So these are the special names given to the various kinds of polygons based on the number of sides they possess, right? So let's look at something special about polygons, right? In terms of angles. So we are dealing with angles, right? So whenever you have a polygon, definitely every polygon has interior angles and exterior angles, right? So let's look at some properties of interior angles of a polygon, right? So we say the sum of interior angles of a polygon can be found using this particular formula, right? And the formula is 180 degrees times n minus 2, right? So if you want to find the sum of interior angles of any given polygon, you just use this formula, 180 times n minus 2, where n is the number of sides of that polygon, right? So we have the sum of interior angles of the various polygons here. So we are going to apply the formula to all the polygons, right, to find out the sum of interior angles of that particular polygon, right? So if you would recall, you would remember that we said the sum of interior angles of a triangle is 180 degrees. So means that answer was derived out of this formula, right? So let's see how we apply this formula to come out with that law that the sum of interior angles of a triangle is 180 degrees. So we said the formula is 180 times n minus 2, right? So n is the number of sides. So for a triangle, the number of sides is 3, right? So it's going to be 180 times 3 minus 2. What is 3 minus 2? 3 minus 2 is 1. So what is 1 times 180? It gives us 180 degrees. That is why the sum of interior angles of a triangle is 180 degrees. For a quadrilateral, still applying the same formula, 180 times n minus 2. So how many sides has a quadrilateral? 4. So it's going to be 4 minus 2, and that gives us 2. So it's going to be 2 times 180. So simply you just subtract 2 from the number of sides and then you multiply it by 180 to get the sum of interior angles of that particular polygon, right? So for a pentagon, what is 5 minus 2? 3. So to get the sum of interior angles is going to be 3 times 180, and that gives us 540 degrees. Hexagon is 6. 6 minus 2 is 4. 4 times 180 gives us 720 degrees. Heptagon is 7. 7 minus 2, 5. 5 times 180, 900 degrees. Octagon is 8. 8 minus 2 is 6. 6 times 180 degrees is 1080 degrees. Nonagon is 9. 9 minus 2 is 7. 7 times 180 is 1260 degrees. Decagon is 10. 10 minus 2 is 8. 8 times 180 degrees is 1440 degrees. On decagon is 11. 11 minus 2 is 9. 9 times 180 is 1620 degrees. Duodecagon is 12. 12 minus 2 is 10. 10 times 180 is 1800 degrees. Yes, so that is that for the various types of polygons and their sum of interior angles, right? Alright, so let's proceed. Okay, let's now focus on irregular polygons. Irregular polygons. So we said a regular polygon is a polygon with all sides and all angles equal, right? So how do you find the size of one interior angle of a regular polygon, right? So we said the sum of interior angles of any polygon is given as 180, right? 180 times n minus 2, right? So whenever you have a regular polygon and you want to find one of the sizes of the interior angle, now since it is regular, it means that all the interior angles are obviously equal. So to do that, you just divide the sum of interior angles by the number of sides of that polygon, right? So it's simply going to be 180 times n minus 2 all over n. As simple as that, right? So the 180 times n minus 2 give you the sum of the interior angles. But then if you want to find just one of the interior angles, you divide the sum by the number of sides. So when I was proving to you why the equilateral triangle has each of its interior angles at 60 degrees, I told you that since the sum of interior angles is 180, to get or to find one of its interior angle, you divide 180 by 3, since a triangle has 3 sides. So 180 degrees divided by 3 is what? It's 60 degrees, right? So that is how to find the value of one interior angle of a regular polygon. So let's look at this practical example here. So how many sides has a regular polygon whose interior angles are 108 degrees each? So we said one interior angle is equal to 180 times n minus 2 all over n. So here we've been given the interior angle to be 108. So you simply equate it to the formula, right? So 108 degrees is equal to 180 times n minus 2 all over n. So you just find the value of n. So you've gotten a typical equation, right? So let's multiply through by the n. So we're going to have 108n is equal to 180n minus 360. So simply you're going to expand this bracket here. So 180n, so 180 multiply the n, it will multiply the negative 2, giving us 180n minus 360. So we group like terms, right? So you're going to have, so what I did was I sent the 108 here, right? So that is subtracted, and I brought the 360 here. But then it doesn't matter which side of the, it doesn't matter which side they appear, right? Once it is an equation, you can place it anywhere, right? So you're going to have 180n minus 108n is equal to 360n, right? So 180n minus 108n gives us 72n. So everything is equal to 360. So to find the value of our n, we divide both sides by 72. So what is 360 divided by 72? The answer is 5. So therefore the polygon has 5 sides. So it is a regular pentagon. A regular pentagon. Right. I believe you're following. Okay, let's proceed. Okay, let's now delve into the exterior angles of a regular polygon. So basically the sum of exterior angles of a polygon is 360 degrees, right? The sum of exterior angles of any polygon at all is 360 degrees, right? So take that point serious, or take note of that point. So if you want to find exterior angle of a regular polygon, that is just one exterior angle, you divide the 360 by what? By n. You divide the 360 by an n, right? Where the n is the number of sides of the polygon. So let's take this example here. A regular polygon has 10 sides, right? Find each exterior angle. So we said the formula is 360 degrees all over n. So it's simply going to be 360 over the number of sides, which is what? Which is 10, giving us 36 degrees. Right? So it means that each exterior angle of a regular decagon, right, is 36 degrees. Is 36 degrees. Right. Okay, let me show you an alternative way of finding the exterior angle of a regular polygon. So obviously the interior angle of a polygon plus its exterior angle will sum up to 180 degrees. Am I right? Yes, I'm right. So if you want to prove that this answer is correct, just go back to the table for, let's go back to the table for the sum of interior angles of a polygon. Okay, so here for the decagon it was 1440, right? So if you want to find one interior angle, just divide it by 10 and that gives us 144. Now subtract 144 from 180 and let's see what you would get. You would simply arrive at 36 degrees, right? So they're just an additional point I'm adding on, right? So that is that for the exterior angle of a regular polygon. Let's now look at this final question here. A regular polygon has an exterior angle of 40 degrees. How many sides has the polygon? Hence, what is the name of this polygon? Right, so we said that to find one exterior angle, the formula is 360 over n. So here we've been given the exterior angle to be 40, so we equate the 40 degrees to 360 over n so that we can find the value of the n, right? So we're going to get 40n is equal to 360. So n is equal to 360 over 40, right? And that gives us 9. So what is the name given to a polygon with 9 sides. That is a nonagon, right? So how many sides has a polygon? It is 9. What is the name of this polygon? It is a nonagon. It is a nonagon, a regular nonagon, right? So that is how to apply knowledge on interior angles and exterior angles of a regular polygon, right? Okay, so this is where we bring the lesson to an end.